Okay, this will be part 2 of z-scores and doing some z-score problems. Okay, so there it is. So what we're going to do today is just a couple more examples. So this is day number 10. Okay, 10. And this will be z-score example problems. Okay, so the first thing that we're going to do is we're just going to do one where we're going to do one like a warranty example. Okay, so something like this. Okay, the manufacturer of watches determines the mean lifespan months here of a watch could be, let's say, I don't know, 75. Just hang on, I'll just pause here. Just give me a second. I'll just pause. Okay, so continuing on with the z-score thing. I'm trying to move this. Stupid. This thing never wants to move when I want it to. Okay, so I typed it out here. I kind of forgot to unpause it. So here's an example. The manufacturer of watches determines the mean lifespan of the watches to be 85 months with a standard deviation of 9.2 months. They want to offer a warranty where they need to replace only 3.5% of the watches. Find the warranty length, what the warranty length should be. So this is another z-score problem where we have to find a result. So we want in here, we want only 0.035 here. So we have to get the z-score at that spot, and then we can use the z-score. So I got that wrong. We want it to last. We don't only want we want them to last. They want to only fix a few of them. So we want to get the ones that will break at that small amount. So it's going to be a very small percentage, right? So no, I had it right. So it's going to be a negative z-score. So if we look at the z-score table and look up what it would be, let's find the z-score table here. All right, so the z-score table in our case is going to be a -1 because these are all above 50%. So 0.035. Okay, so 0.035. 0.035. Okay, oh, gotta go this way. Sort of in here. Okay, so 0.03515 is about the closest we get. So -1.81 is our z-score for that. So that's to the left of that. Okay, so our z-score was equal to -1.81, and that gave us 0.3515, so it's a little bit more. And that would be all the ones that break. So if we go x is equal to, if you remember the z-score formula from before, it's let's see here. It's, well, just in case you forgot, I better write it out the right way. So Z equals X minus the mean over the standard deviation. So that if we want X by itself, we have to multiply by the standard deviation on both sides. And then we have to add the mean to both sides. Okay, so what should this warranty be? So we got negative 1.81 times standard deviation of 9.2 months plus the average that we have, which was 85 months. Okay. So we just multiply that out. Okay, so we got a negative 16.65 plus 85. So I'm going to round it off. I get 68.36. I'm going to go 68 months. So therefore, so they should offer a 68-month guarantee or warranty. So that means there's only going to be 3.5% that aren't going to make it to that 68 months. Okay, which is that spot on the curve. Okay. So similar question to what we did last time for an example. So let's do another example, but let's do an example with an in-between one. Okay, so let's see. Let's do one where you have to find two z-scores. So that's the other kind of example that was happened. So something like this one. Okay. A company makes, let's go with something that's variable. Let's say, what's an example of things that are variable here? Let's say a company makes tarp straps. With an average length of, let's say, 32 centimeters, having a standard deviation, or with a standard deviation with a standard deviation of, let's say, I don't know, 1.4 centimeters. Okay. The company makes 5,000 straps and a day. That's kind of low, but whatever. Find the number of straps that fit into the range of, let's say, 30 to 35 centimeters is what they need. Okay, so that's a good one there. So the first thing we've got to do is we've got to kind of figure out what we're doing. So we're going to have two limits. We're going to have a left limit and a right limit on our tarp straps. So we're going to have a normal, of course, we're assuming normal distribution. So over here, we're going to have 35 centimeter ones. And over here, we're going to have the 30 centimeter ones. They're going to be below. The mean is 32. And then 30 centimeter ones are going to be, and we want to find out what the percentage is of this area between those two z-scores. If we figure out that percentage of that area, we then can multiply it by 5,000 to get how many straps were made. Okay, so the first thing we're going to have to do is we're going to have to calculate the z-score here and calculate the z-score here. So step one, calculate the z-score of both limits. We'll call it edges. Okay, this edge and this edge. So z-score we're just calculating, so we don't have to rearrange it or anything to get that number. So z-score formula is the point minus the mean, which is a fancy U, over standard deviation. So in our case, we're going to do this one first. So we'll go 30 minus 32 over 1.4, because that was our standard deviation, I believe, right there. Okay, so if we do that, that's 2 over 1.4. So our z-score there is 1.43. So that's our z-score, 1.43. Okay, and now we have to find the other z-score, z-score 2. Okay, that's going to be 35 minus 32 over 1.4, and that's going to equal 3 over 1.4, and that's going to equal, oh, sorry, this is negative. What am I doing here? Negative. Hope you caught that. 30 minus 32 is negative 2, not 2. All right, so this is 3 divided by 1.4. So this is 2.14 z-score. And that's positive. So now we use the z-score table to look up the percentages to get the percentage in between. So the left one is going to, this one, the 2.14 is going to give us all this area. And then the right one, the negative 1.4, is going to give us just this area. And we can take this one and subtract this one to get this middle area. So we're going to go in step 2, after we calculate the z-scores, is we find the areas and subtract them. Okay, so step 2, use the z-score table. Find the areas for each edge. Find the percentages area for each edge. Okay, so in that case, we got to get that z-score table up. All right, so there's our z-score table, and we're looking for negative 1.43 first. Negative 1.43 is Negative 1.43 is right here. So it's 0.7636. 0.7636. Okay, so this one here, this area, (0.07636). Okay, and then we're going to look up 2.14. Two point one four is right there. It's 99.266. 99.266. So this is positive 2.4. So the percentage that fit in between that, we have to subtract them. So now what we're going to do, this one is bigger than that one. So to get the area in between, we subtract the two. So step 3, subtract the percentages. So 0.99266 subtract 0.07636. So this is going to give us the percentage that is in between those 2 points. 0.36190. So we've got 0.91360. So that means we have 91.63% between those two z-scores, or 30 centimeters and 35 centimeters. Okay, so now if we want to get the number, step 4 is to find the number. We want 91.36% of 5,000. So we just multiply it by the decimal number. So 5,000 times 0.9163. So I get 4,581 and a half. So 4,581 straps. Okay, so that is how you do those ones. So now we'll just give you some practice examples to work on from the last 2 days here. Okay, and then that'll leave us with one section left in this unit. Yay! Okay, so let's do page 264, 265. Okay, so you can do 1A and B, 2A and B for practice. Okay. 5A and B. 6A and B. Okay, that's just some working. Okay, and then we can do some results. We can do 10 word problem. Let's go with, let's go 12, 16, 17. That should be good. You can do those ones, you're doing good. And then we'll do confidence intervals next day. So that takes us through standard, Z scores.